Hello, my name is David Francis and I'm the CEO and co-founder of Virtual Method in Sydney, Australia. This Friday afternoon, beautiful weather, thought I would get outside and show you something that's a bit of a proprietary technique that we've put together at Virtual Method for the capture of 3D scenes. When you're in an emergency situation, when you have a car crash or you have you're on a mine site and some vehicle is flipped or whatever, and you need to take a record of that situation. Some people now are using drones, so they'll fly a drone up, it'll take a lot of photos and they'll stitch those photos together, but a drone operator to do that has to be highly skilled, in the right place at the right time therefore, and that skill costs a lot of money too, by the way. You have to have an expensive drone, and in a lot of these situations where you have live wires and all that sort of thing, it's just not practical to be using a drone. And you know, when people are injured, etc. on the ground, to have this buzzing drone above them is not the best thing. So what I'm going to show you today is a technique that we've invented using the RealWear HMT-1, which is a device that we actually sell and integrate and support out of our company, and also the Librestream Onsight Cube, which is both of these are effectively ruggedized high-end devices. This is Android powered, can run multiple applications, collaboration, etc. And this device can do the very same, just in a different way. They actually tether together. So what I'm going to be doing is I'm going to be using this device to take photos around that little vehicle over there, which looks like it's been in an accident, but it's actually an artwork down here at Walsh Bay in Sydney. And I'm going to take multiple photos down on a ground level. I'm then going to move it up, and this pole actually extends up 3 meters into the air, so I can get those downward shots and all those angles that I'm going to need to stitch it together into a 3D model that's going to be very useful for people who want to know what happened at this accident site when they're reviewing it later for insurance purposes or legal purposes, etc. So here we go. So I've got the headset on. I've actually tethered it wirelessly to the cube. This camera can shoot 16 megapixels. This camera shoots a very respectable 13 megapixels, high resolution photos. And literally I can take a photo just by saying to it, take picture. Done. So you can see how easily now I'm going to be able to move this around in any height and I can actually aim and see that I'm getting the right photo just through this little heads-up display right here. I can even set this camera up as just a remote sort of CCTV camera actually, if I wanted to get, you know, 2 pairs of eyes on a site. And I can actually go into a call right now, and anyone remotely anywhere in the world can see through either this cube and they can swap to my headset. I could have a whole array of these cubes and headsets, and they could be able to get eyes on any aspect of the scene that I'm in right now. So here we go. Hello again. So took me about 20 minutes to get the amount of photos that I wanted to get around that smashed up vehicle in the middle of the street there. Being the middle of the street, got a few strange looks. Not many people have seen voice activated wearables before and cameras up poles, but I guess it's something that they'll get used to in the near future. So I've come back to the office and I've plugged my HMT-1 device into my fairly powerful RTX 2080 powered computer, and you can see I've got all these images and they've come up really, really nicely actually. I'm very, very pleased with how they've turned out. I'll show you sort of a larger image. Let me just get rid of that for a sec. There you go. So I'll open a few of them at once. So you can see the images have turned out quite nicely there. You can see as we go around, and that's 13 megapixels, and then you can see I've gotten higher and higher. I'm getting those sort of overhead shots there. And in any case, ready to start compositing them into 3D. All right, so I've composited all the images. I think there's about, how many images? I think there was about 60 566 images all up, composited them together and assembled them using the Photogrammetry software. The result is actually really good. I'm actually really quite happy with how that's turned out. You can even see the strange face someone's painted on that rock there. But yeah, really great little tool for being able to then inspect that scene in, you know, as it was at the time of, say, the incident, and do some, you know, assessments as to causation and how to avoid such an big issue in the future as a huge rock dropping on your car. And also I can then export that model and I can view it in something like a Oculus Quest 2 or a HoloLens 2. Really great way for me therefore to 6 degrees of freedom walk around it, even put it into a tool where I can manipulate the model, do measurements, all that sort of stuff. Hope you enjoyed that. Hope you enjoyed that sort of unique take on how to use ruggedized devices in the field to capture very valuable imagery and then convert it into an AR/VR compatible format. This is why we kind of straddle all these worlds to bring all that technology together in ways that I guess a lot of people may not have thought of. If you want to find out more, find out how all this technology can apply to your organization, your enterprise, please reach out, virtualmethod.com.au. Have a great weekend.